Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, guys, we are going to be tackling question 3 from the grade 12 mathematical literacy paper 2 that was written by the Gauteng province learners, right? Question 3, guys, deals with volume, right? So we're going to be calculating the volume of a rectangular prism. We're going to be calculating the volume of a triangular prism, right? It deals with conversions. We are going to be converting feet to meters. We are going to be converting meters cubed to liters, right? So if you know that you're currently struggling with those topics, please make sure that you watch this entire video tutorial, guys. We are also going to be doing our temperature conversions, where we convert temperature in degrees Celsius to temperature in degrees Fahrenheit. Okay, before we get started with today's video tutorial, guys, please make sure that you are subscribed to the channel. Please make sure that you click on that notification bell so that you get notified every single time I upload a new video tutorial, guys. And also don't forget to give this video tutorial a huge thumbs up, because that really helps the channel grow and it helps the channel to reach more learners that want to better their mathematics marks. If you also want to support the channel, guys, please consider becoming a member of the channel, right? It's only 19 rand 99 cents if you really appreciate the content that I am giving to you guys here, right? Also, don't forget to take a screenshot of this page as well as this page, right? Try this question on your own, guys, before you have a look at this video tutorial. Try it on your own. Once you've tried it on your own, play the video tutorial to basically see if you were able to answer the questions accordingly. Okay, that is the most effective way that you are going to learn. Just copying down the memo and just watching without having any effort on your side is not gonna do you any justice. So you need to try these questions on your own so that you see where you are lacking. And then when you play the video tutorial, you are able to learn and grow and become better, because now you'll understand where you made your mistake and then you won't make that mistake anymore. Okay. Right, so let's get started with today's video tutorial. Let's have a look at question 3. It says Mrs. Palazzi would like to have a swimming pool at her house. She is comparing the size of two shapes of swimming pools, right? There's pool A, which is rectangular in shape with the depth increasing uniformly from 3 feet to 9 feet. Okay, so the depth increases from 3 feet to 9 feet, because the total depth there now is 9 feet. Okay, pool B is cylindrical in shape with a diameter of 5 meters. Okay, so the diameter of our pool B, right? If we assume that that is our center, then our diameter from the circumference going through the center to the circumference is equal to 5 meters. Okay, below are the diagrams of both pools. So we've got the diagram for pool A, which is rectangular in shape, but we do see that we've got two types of shapes, right? We see that rectangular prism at the top, we see that triangular prism at the bottom. Okay, and then we've got pool B, which is a cylindrical shape. Okay, we're also given the pool dimensions, right? We are told that the length of pool A is 40 feet. So the length from there to there is 40 feet. Okay, we are given the width and we are told that the width is 25 feet. So the length from the width from there to there is 25 feet. We are also given the first depth, right? For our rectangular prism, the depth is 3 feet, okay? And then the depth for our triangular prism is 6 feet. So the depth from there to there is 6 feet, okay? They also indicate the height for our triangular prism. So that is the height of our triangular prism. Let me just make it in yellow. Okay, so if this is my height for my triangular prism, that means that this will be my base, right, for my triangular prism. Okay, so that is what is given to us. Okay, we are also told that the following formulas may be used. Okay, we are given the area of a rectangle. So how you calculate the area of a rectangle is length times width. Okay, so it will be length times the width, right? So if you just want to calculate the area, you would look at the top view, then you take that length of 40 feet, multiply the width of 25 feet, okay? We are given the area of a triangle. So the area of this triangle, if you looked at it from a side view, would be half of the base times it by the height, okay? We are given the area of a circle. So if you looked at our cylindrical shaped pool, if you basically focused at the top view, right, the area would be pi times the radius squared. And we told what the pi is equal to, and the pi is equal to 3.142. Okay, and then we're also told how you can calculate the volume of the cylinder. To calculate the volume, guys, we already know volume is equal to the area multiplied by the height or multiplied by the depth, right? So to get the volume of the cylinder, right, you just take pi times your r squared multiplied by the height. So that would give you the volume. How do you calculate the circumference of your circle, right? So to get your circumference, guys, we know that the circumference, right, is basically the outline of our circle, right? Therefore, the formula to get the circumference is pi times your diameter, right? We're given what your pi is equal to. We are told how we can convert from meters cubed to liters. We are told how we can convert from feet to meters. So we're going to use all this information to help us answer questions that are given to us. Okay, so let's look at question 3.1. Question 3.1 says that explain what the term circumference means. Explain the term circumference. So what do they mean when they talk about a circumference, right? So I already said, guys, the circumference is basically the boundary of your circle, the outline of your circle. So if you had to basically put a string around or a rope around the outline of that cylindrical pool, right? And you had to basically now take that rope and put it against like a measuring tape, you would get what the length around this outline of our pool is. Okay, so the circumference is the total distance of the outline of a circle, or the total length of the outline of a circle. Okay, so let's write that down. All right, and we are basically done. Let's have a look at question 3.2. Convert the length of the rectangular pool to meters. All right, so here we want to convert the length of the rectangular pool to meters. So what is the length, guys? We already know that the length is your longest side, okay? So we have to now basically get what the length is of our rectangular pool. Then we want to convert that length to meters, okay? We're already given here, they already made that easy for us. They told us that the length of our rectangular pool is 40 feet. So we want to now convert those 40 feet into meters. How are we going to convert the feet to meters? We're going to use this conversion that was given to us here, right? Which is 1 foot is equal to 0.3048 meters. Okay, so we're going to use this to help us to convert feet to meters. Let's write that down. So we already know that 1 foot is equal to 0.3048 meters. We want to convert 40 feet to meters. So what do we need to do, right? Guys, I've been singing this song ever since, all right? So at this point, everyone, if you're a day one, right, a regular, then you should know what you need to do at this point, okay? So if you want to convert from feet to meters, all you need to do is you need to multiply by what you want. What do we want? We want our units in meters. So we're going to multiply by 0.3048 meters. Okay, and then you divide by the units that you already have, which is 1 feet. Okay, what happens here, guys, right? Okay, you already see that 40 feet divided by 1 is this. It's just the same as saying 40 feet, but I'm just writing it as a fraction so that you guys see which units are converting. Okay, so the feet and the feet cancel each other, right? Then what do we see? 40 multiplied by 0.3048 meters, right? Okay, then what do we see? You can just say 40 multiplied by 0.3048 meters, right? And that will give you what the answer is from feet to meters. So our final answer is 12.192 meters. All right. And we are done. Let's have a look at the next question. Question 3.3. Mrs. Palazzi claims that pool A can hold over 169,000 liters of water. If the volume of water of section A of her pool is given as 84,951 liters, determine whether Mrs. Palazzi's claim is correct. Okay, so she is claiming that pool A, right, this pool can hold over 169,000 liters of water. Okay, then we are told that the volume for section A, right, is equal to 84,951 liters. So if the volume for section A is equal to 84,951 liters, what would the volume for section B be, right? In other words, what this question is trying to what we basically need to do is that we basically need to determine what the volume for section B is, right? And when we add the volume of section B to the volume of section A, right, we should get the total volume of the pool as value that is over 169,000 liters. Okay. So how will we basically calculate the volume for our section B, right? So when you're basically calculating the volume of this triangular prism, all that we need to do, volume of a triangular prism, is going to be half your base, okay, multiplied by height, multiplied by this width, right? That is how we're going to get the volume of this rectangular prism. Okay, but just for interest's sake, let me just quickly show you how they calculated the volume of section A. Okay, how did they calculate the volume of section A? They took your area of your section A multiplied by the depth. So they took that 40, your length, multiplied by your width of 25, multiplied by the depth of 3. However, you have to first convert that 40 feet, the 25 feet, the 3 feet into meters, okay? And then from there, that's how they got their volume of 84,951 liters, okay? They first got their answers in meters cubed, right? And then they converted that answer of meters cubed into liters, right? And then that's how they basically got their volume, okay? I'm just going to quickly show you how you would calculate that just for interest's sake, okay? Because guys, at the end of the day, you guys are here to learn, okay? Not just to check out the memo, because the paper that you're going to write on Monday, on the 11th of September, I think that's when you're writing your paper 2, is not going to be the same as the paper that was written in 2022. Okay, so what's important is that you guys understand the concepts. How do you calculate volume? How do you calculate the volume of a rectangular prism in any given situation? Okay, so that when they give you any question, you can basically answer that question. Okay, so I'm going to show you quickly how they calculated that volume. Okay, and then what they did is, right, they basically converted, okay, the 40 feet into meters. They converted the 25 feet into meters, and they also converted that height of 3 feet into meters. So let me just show you how they did that. Okay, so basically here I've converted all the feet, right, to meters, right? And then from here, all we need to do, you should basically substitute all your values, which is 12 12.192. Remember, with mathematical literacy, guys, we only round off your final answer just for accuracy. Okay, so 12.192 multiplied by 7.62 meters multiplied by 0.9144 meters. Okay, so if you punch it into your calculator, what do you get? Okay, you'll find that the volume, right, of section A of the pool is 84.95053,978 meters cubed. Okay, because you've got that meter there times meter there. Okay, so it's going to be meters cubed. Okay, which is approximately, if you round it off to 2 decimal places, 84.95 meters cubed, right? However, we want what the volume is in liters. Okay, remember we were given here how you can convert from your meters cubed into your liters, right? We were told that 1 meter cubed is equal to 1,000 liters, so we can convert that 84.95 meters cubed into into liters. Okay, we already know that 1 meter cubed is equal to 1,000 liters, right? So to basically convert these meters cubed into liters, we are basically going to take that 84.95 meters cubed, multiply by what you want, which is your units in liters, divided by what you have, which is your units in meters cubed. Okay, then what do we notice is happening here, right? Your meters cubed cancel, and the answer that you'll have here will be your answer in liters. Okay, so you'll have 84950.53,978, right, which is approximately 84951 liters. Okay, so that is basically how they got the volume for section A of the pool. How do we now calculate the volume of section B? Because remember, we want to basically find out what is the volume of section B. We already have the volume of section A. We want to see if you add these two volumes together, do we get a number of liters that is over 169,000? Okay, that's basically what we're trying to check. Okay, so now let's basically go back to what the question was asking us, right? The volume of the section B is equal to, right? How do you calculate the volume of a triangular prism? It's going to be half base times height. So how would we basically get the volume of our triangular prism? Okay, how you basically get, guys, the volume of a triangular prism is that you first basically calculate the area of your cross section. Okay, so this would be the area of your cross section. Okay, how would you get the area of this? Right, we already know to get the area of the cross section, this is called a cross section, right? You would just say half the base multiplied by the height. Okay, that would be the area of the cross section. Then after you've basically determined the area of the cross section, you still need to multiply that area by width, right? This width of 25 feet. Okay, so let's just quickly write that down. Okay, and then we said what is the cross section? To get the area of a triangle, guys, we're already given what the formula is, right? We're told that it's half base times height. So we're gonna write half base times height, okay, multiplied by the length. Okay, but then I don't want to really say length here, because if I say length, then you guys are going to be confused and think that it's supposed to be that 40 feet. So I'm just going to say that width there, okay, because we've already accounted for the base, we've already accounted for the height. What have we not accounted for? It's that width there. So I'm going to write it as width just so that no one gets confused, okay, right? And then we are basically going to substitute all the values that are given to us. Okay, but before we can even substitute, we need to get what is the base. What is the base equal to, right? So the base is that 40 feet. Okay, so in this case, before we can even substitute all our values into our formula, we need to ensure that all our units have been converted from feet to meters, right? Because we want the volume in meters cubed. So let's just establish what is our base, what is our height, what is our width, right? So the base in this case, right, is going to be that 40 feet, right? That is our base. What is going to be our height? Our height is going to be that 6 feet, okay? And then what is going to be our width? Our width is going to be that 25 feet. Okay, so I've basically written that down. Our base is 40 feet, so we need to convert those into meters. So that's 12.192. We already did that in the previous question, right? We need to convert the 6 feet into meters. So if you take the 6 feet, multiply by 0.3048 meters, you will get 1.8288 meters. And if you take 25 feet and you multiply by 0.3048, right, you will get 7.62 meters. Okay, so that is basically how you're supposed to convert from feet to meters. Guys, this part is very important. You need to show these working out because they count marks. Okay, that is very important. Do not skip this part out. Okay, show the working out. Right, so now we've got all our values here. All we need to do is we need to substitute our values into our formula. Okay, and then if you punch that into your calculator, right, what do you get as your volume of section B? Okay, I'm just going to leave that a half. Then I'm going to get what the value is. If you take the 12.192 times 1.8288 times 7.62, okay, so you're going to multiply that half with 169.9010796 meters cubed, right? So in other words, if you divide this by 2, the volume of section B is actually equal to 84.95053978 meters cubed, which is approximately 84.95 meters cubed. Okay, right? So that is what the volume of section B is. Okay, however, guys, we want the volume to be in liters. Okay, because remember, we want to basically determine if this pool can hold over 169,000 liters of water. So we need to convert these meters cubed into liters. Okay, so we already know that 1 meter cubed is equal to 1,000 liters, right? So we're going to use this to convert the meters cubed into liters. Okay, therefore volume of section B, right, is that 84.95 meters cubed multiplied by what you want, which is your units in liters, divided by what you have, which is your units in meters cubed. Okay, if you punch that into your calculator, you will get that the volume of section B in liters is actually equal to 84,950 liters. Okay, so now we already know what the volume is for section A. We already know what the volume is for section B. Therefore, the total volume for the pool is equal to, we're already given what the volume was for section A, and it was given as 84951 liters. Okay, so it is 84951 liters. What is the volume for section B? We calculated that the volume for section B is 84950 liters. Okay, so if you punch these two values into your calculator, what is the total volume that you're getting for your pool? So how many liters of water can this pool hold? This pool can hold 169,901 liters. Okay, so what does that say now about the question? Remember, Mrs. Palati claims that the pool A can hold over 169,000 liters of water, and we've calculated this pool can actually hold 169,901 liters. So this is actually a value that is over, greater than 169,900 by 1. Okay, so we can see then that in this case, Mrs. Palati's claim was correct. So therefore, her claim was correct. Okay, pool A can hold over 169,901 liters of water. Okay, Right. So with this question, guys, question 3.3, I hope you guys really followed with me attentively, okay? Because in the memo, the way that they've done this question, I think it would be a bit confusing because in the memo, they've just only just divided at the end. Right? They didn't really show the dividing in their calculations. And I think that can cause a bit of confusion. To get the volume of this triangular prism, you need to basically take the area of the cross section and then you need to multiply it by that width. That is how you need to calculate it. You can't just divide after by 2. So that's where I disagree with the memo, okay? You needed to just include that in the calculations to get what the volume of the section B is. And then from there, we convert that volume into from meters cubed to liters, right? And then from there, if you add the volume of section A plus the volume of section B, you'll find that actually the amount of water that this pool can hold is over 169,000. Okay, so I hope I didn't lose anyone there. Okay, all right, let us have a look at question 3.4. Okay, choose the correct letter that will make the following statement true. So which letter would make the following statement true? The formula to calculate the volume of pool B is, how do we calculate the volume of a cylinder, right? Quick recap, we already know that, okay? If you've been watching all my video tutorials where I've been going through cylindrical shapes and how you calculate volume of a cylinder, right? You know that a volume of a cylindrical shape, right? You basically say the area of that cross section, right? Which is the circle multiplied by the height. Okay, and then how do we calculate the area of a circle? It's your pi r squared multiplied by height. So this is how you need to basically calculate a volume of a cylindrical shape, right? Or this formula can be written as volume of the cylindrical shape, right, is equal to the radius is the same as saying your diameter divided by 2. So you can just write it as pi. What is r? Radius is the same as saying d divided by 2 all squared multiplied by height. Okay, so these are the two formulas that we can use to basically calculate the volume of a cylindrical shape. So in other words, if you can just simplify this, this is the same as saying pi d squared is d squared over 4 multiplied by height. Okay, so now we're going to have a look at the statements that are given to us, and we basically need to have a statement that either resembles pi times d squared over 4 times height, or a statement that resembles pi r squared times height. Okay, so let's see. So here they've basically substituted our values there. So let's just quickly substitute. Né? So if you were to basically substitute the values that are given to us, right? We've got pi. What is our r here? R, we're not given. So that'll be 5 divided by 2 is your pi. So it's 5 divided by 2, right? So your r is 5 divided by 2, okay? Because guys, remember, your radius is equal to your diameter divided by 2, okay? Right? So in other words, if we just wanted to get our radius here, we can just take that 5 divided by 2, and 5 divided by 2 is 2.5 meters. Okay, so let's just write it like that then. Okay, it's going to be pi times 2.5 all squared times it by your height. Okay, so that is how we basically need to calculate this volume. Our answer or our statement needs to say pi times 2.5 all squared multiplied by your height. Okay, so let's have a look. Okay, so we see that statement B is therefore correct because we see that to get the volume of pool B, it's pi times 2.5 all squared times height. So B is the correct statement. Let's have a look at question 3.5. Pool B is estimated to hold 65,000 liters of water, right? Determine the depths of pool B and round off your answer to 2 decimal places, right? So we already given what the volume is going to be for your pool B. And we are told that the volume for pool B is 65,000 liters, right? Now, we basically need to now use all the information that is given to us to determine what the depth of pool B. What is the depth, right? How deep is this pool there? That is the depth that they are looking for. Okay, so how would we go about calculating the depth of our pool B? We need to basically start off with the formula for calculating the volume of pool B. And in this case, it's already easy because we already know what the formula is. If you've got question 3.4 correct, we know that the volume of pool B is equal to pi r squared multiplied by the height, or you can say multiplied by depth. Okay, so you can even write it as pi r squared multiplied by the depth. That is also correct. Okay, right. And then what do we already know? What is the radius of our pool B, right? We already know that the radius is equal to the diameter divided by 2, right? I'm just going to do this mini calculation here, right? So the radius is the diameter of 5 meters divided by 2. So we know that our radius is supposed to be 2.5 meters, okay? We've already shown this in the previous calculation. That is why I'm just doing this note on the side, okay? So all that we need to do, you can just simply substitute all our known values, right? We know that your pi, right? Remember, they told us what your pi is supposed to be equal to. They said pi is equal to 3.142. So please use that value of pi that they have basically given to you in the question, okay? But before that, let's just write that down. So it's going to be pi multiplied by, what is your radius? 2.5 all squared multiplied by, we want the depth of the pool. So I'm just going to actually just write it as D, okay? And then what is the volume of pool B? They gave us what the volume is in liters. Do you see that? They said that the volume or the amount of water that pool B can hold is 65,000 liters of water. Guys, here we don't just now go and substitute that 65,000 liters of water into this formula. Why can we not do that? Remember, the radius of this pool is in meters. Okay, our radius is in meters. So we cannot just write 65,000 liters. We need to ensure that the units for the volume is in meters cubed. Okay, first. Then from there, we will be able to basically determine what the depth is in meters. So this is basically where most people are probably going to get this question incorrect, okay? Because you need to ensure that your units are correct. You have meters, so your units need to be in meters, not liters and meters. Okay, so in this case, we need to convert the 65,000 liters into meters. We know 1 meters cubed is equal to 1,000 liters. So we've got 65,000 liters multiplied by what you want. You want your units in meters cubed, divided by what you have, which is your units in liters, right? So 65,000 divided by 1,000 will give you 65 meters cubed. Okay, so now that we have our units in meters cubed, we can basically substitute that into our formula. We've got 65 meters cubed, right? And then we can continue to now solve for our unknown, which is the depth of the pool. Okay, so we've got 65 meters cubed, which is equal to 3.142 multiplied by 2.5 all squared multiplied by the depth. Okay, so I'm going to simplify the right hand side. So 3.142 multiplied by 2.5 all squared will give you 19.63 0.375 times it by d. And then remember here, we're going to have our units as meters squared because the meters are squared, right? Times it by the d, which is your unknown. And then if you divide both sides by 19.6375 meters squared, divide by 19.6375 meters squared, right? You'll get that your d is equal to, actually even depth, let's just write it as your depth is actually equal to 65 divided by 19.6375, and that is 3.309993635 meters, right? Because here we see you've got meters cubed, meters squared, right? Same base, you subtract your exponents. That means that you have your units in meters. This is grade 9 stuff. That's why you should be able to understand what I just did there. Okay, so in this case, the units that you'll have for your depth is meters. So that is approximately equal to 3 point, okay, because they said that we need to basically round off our answer to 2 decimal places, right? That basically means that our answer is going to be 3.31 meters is our depth. Okay, so I hope everyone was basically still following with me there, right? It was a bit detailed, okay? So that is basically the depth for our pool B. Okay, let's go on to the next question. Question 3.6. Pool B is filled with water at a rate of 1.5 meters cubed per minute. Okay, so pool B is filled with water at a rate of 1.5 meters cubed per minute. Okay, so for every 1 minute, if they say the rate is 1.5 meters cubed per minute, okay, that basically means that in 1 minute, right, we would have basically filled up 1.5 meters cubed of the pool. That is basically what that means, okay? And then they say, hence, Mrs. Palati claims that it can be filled to 92% of its capacity by 8 a.m. if the filling process starts at 7:30. Verify whether Mrs. Palati's claim is correct. Okay, so in this question, what we basically need to first do is, if they say that pool B is going to be 92% full, right? How much is 92% of 65 meters cubed? Okay, or how much is 92% of 65,000? Okay, and then once we're able to basically determine what is that 92% of 65,000 liters, right? Then we will be able to then now work with the rate that is given to us to determine whether the pool will be filled to 92% of its capacity by 8 a.m. Okay, so let's just first calculate what is 92% of 65,000 liters. Okay, so what we want to basically determine is what is 92% of 65,000 liters? What is 92% of 65,000 liters? Okay, so we already know that when you see that of, you're just going to basically multiply. Okay, 92% is the same as 92 divided by 100 multiplied by 65,000 liters. Okay, so if you punch that into your calculator, you'll get that 92% of 65,000 is actually equal to 59,800 liters. Okay, so when she basically says that by 8 o'clock, the pool will be filled to 92% capacity, she is basically saying that, okay, at 8 o'clock or by 8 o'clock, right, the pool would basically have 59,800 liters of water. Okay, so now we've basically just found out how many liters of water would be in the pool if it's filled to 92% of its capacity. However, we want to see if the time frame basically matches. Okay, will the water be filled up at that time. So we are already given the rate in which the water is filled. We are told that in 1 minute, we would have basically filled 1.5 meters cubed of water. Okay, so same thing here. Before we can even work with this conversion, we first need to convert our liters to meters cubed, right? And you already know that 1 meter cubed is equal to 1,000 liters. So you're going to take that 59,800 liters multiplied by what you want divided by what you have, which is 1,000, right? Okay, and if you punch it into your calculator, you'll find that 59,800 liters covers a volume of 59.8 meters cubed. Okay, so now with this, we basically need to determine how long it would take to fill 59.8 meters cubed, right? Using this conversion that was basically given to us, right? So in other words, we're going to take that 59.8 meters cubed. We want to convert these meters cubed into minutes because we want to determine how long it will take, right, for us to fill this pool. Okay, so you're going to multiply by what you want. You want your units in minutes divided by what you have. Okay, so you want our time divided by your 1.5 meters cubed. Okay, so what do we notice here? If you punch that into your calculator, you will get 39.8667 minutes, right? So approximately for us to basically fill up 559.8 meters cubed, right, of the pool, you will need like 39.8667 minutes. Okay, so that is like approximately 40 minutes to fill up our pool. Okay, so in other words, if you basically start filling the pool at 7:30, right, and you add 40 minutes, that means that we will be done filling, we would have filled up the pool to 92% of its capacity at 8:10 a.m. Okay, so what does this basically tell us? Okay, so I'm basically going to show this. If you basically take, okay, so if you take 7:30 a.m. plus 40 minutes, right, that will basically leave you at 8:10 a.m. Okay, and then what does this tell us? Okay, and therefore here, actually, we could conclude that her claim is not correct. She said that the pool will be basically filled up by 8 a.m. in the morning. However, we found that the pool will be only filled actually to 92% of its capacity by 8:10. Therefore, her claim is not correct. Okay, her claim is not correct. Okay, the pool will only be filled up to 92% of its capacity by 8:10 and not by 8 a.m. Okay, I hope you guys got that one. Let's have a look at the next question. Question 3.7. Mrs. Palati chose pool A. Gave one possible reason why she opted for pool A, even though pool A uses more water than pool B. Okay, so when you basically look at what's given to us here, right, we are told that Mrs. Palati basically decided to go with pool A, right, even though pool A basically takes 169,000 liters of water. However, pool B takes 65,000 liters of water. So we can see that pool A takes quite a significant amount of water compared to pool B. So why do you think she could have gone for pool A, okay, and neglected the fact that pool A uses a lot of water? Okay, so I'm basically thinking she could have probably went for pool A because the design of pool A is more modern. Okay, who wants to have pool B in their yard, guys? Honestly speaking, okay, let's be more modern. Okay, so I'm guessing she basically went with pool A because the design of the pool is more modern. It looks nicer. It's aesthetically pleasing to the eye, right? It looks good on the gram. Okay, so that is probably why she went for pool A. Okay, so the design of pool A is modern. It's nicer. It looks pleasing, right? as compared to pool B. Let's have a look at question 3.8. When Mrs. Palati wanted to swim in her pool, the temperature of the water was 19 degrees Celsius, and she said she would only swim if the temperature of the water was 25 degrees Celsius. The temperature must increase by 6 degrees Celsius. Calculate what the temperature change would be in degrees Fahrenheit, right? You may use the following formula. Okay, so very important for this question, guys, right? Please, okay, do not first take 25 degrees Celsius and you subtract it with that 19 degrees Celsius, right? To get that, oh, okay, that means that the change in temperature must be 6 degrees Celsius. And then now you want to basically substitute that degrees Celsius into this formula to then get what the temperature would be in Fahrenheit. Guys, we cannot use that approach to help us calculate or to help us solve this question. And the reason being is that the scales for your temperature as well as your Fahrenheit are different, okay? In a sense that, for example, the when you look at your Fahrenheit, okay, the freezing point for water when you're dealing with your Fahrenheit is 32 degrees Fahrenheit. However, the freezing point for water, right, when you're dealing with degrees Celsius is 0 degrees Celsius. Okay, so they've got basically they have their own thermometers for measurement. So we can't just now just subtract your 25 degrees Celsius from your 19, right? And then say that, okay, that is what the change is. And then from the substitute, we first need to calculate what is this 19 degrees Celsius in Fahrenheit? What is this 25 degrees Celsius in Fahrenheit? And then we can now determine what the change in temperature is supposed to be. Okay, so I hope I didn't lose anyone there. Okay, we first need to convert each of these temperatures from degrees Celsius to degrees Fahrenheit. Then we determine what the change in temperature. Okay, so we are given for us to convert from degrees Celsius to Fahrenheit, we need to basically use this formula that is basically given to us. I'm going to rewrite the formula here. Okay, so that is the formula we're supposed to use to help us convert our degrees Celsius to degrees Fahrenheit. Okay, however, I'm just going to manipulate my formula, change my formula around a bit, okay, and make my degrees Fahrenheit the subject of the formula because that is what I'm trying to get. I'm trying to get my temperature in degrees Fahrenheit. So before I substitute the given values into this formula, I want to basically first isolate my degrees Fahrenheit. So how can I do that? This degrees Fahrenheit minus 32 divided by 1.8 can also be written as your degrees Fahrenheit minus 32, right, divided by 1.8 is equal to degrees Celsius, right? Meaning I want to basically isolate my Fahrenheit, so degrees Fahrenheit, right? So what do I need to do? It's going to be degrees Fahrenheit minus 32. What is the inverse of division, right? The inverse of division is multiplication. So for me to get rid of that 1.8 on the left hand side, I need to multiply by 1.8, okay? So the inverse operation. So what you do on the left hand side, you need to do on the right hand side. So it's going to be 1.8 degrees Celsius, okay? And then what's left for us to do? You've got a negative 32 on the left hand side. I want to get rid of this negative 32. So I need to do the inverse operation of subtraction. So I'm going to plus 32 on the left hand side to get rid of the 32 on the left hand side, okay? And if I've plussed on the left hand side, I need to plus on the right hand side, okay? So therefore negative 32 plus 32 is 0, so your degrees Fahrenheit is equal to 1.8 degrees Celsius plus 32. So we basically have our formula in its simplest form, and all we need to do now is we need to change the temperature of 19 degrees Celsius to Fahrenheit, of 25 degrees Celsius to Fahrenheit by just putting it into our equation. Okay, so I've made our lives very easy. Okay, so let's just put that into our formula. So we're going to basically take your to get the degrees in Fahrenheit for your 19 degrees. Okay, I want to convert the 19 degrees Celsius, right? So I'm going to take degrees Fahrenheit is equal to 1.8 degrees Celsius plus 32. So where I see degrees Celsius, I'm going to substitute that 19 plus 32. If you punch that into your calculator, what do you get? You will get 66.2 degrees Fahrenheit. Okay, so we've basically converted the 19 degrees Celsius to Fahrenheit. The next one, we need to convert 25 degrees Celsius to Fahrenheit. So what do we need to do? We're going to use the formula again. Degrees Fahrenheit is equal to 1.8 degrees Celsius plus 32, which is going to be 1.8 multiplied by 25 degrees Celsius plus 32. Okay, punch that into your calculator. You'll find that you will get 77 degrees Fahrenheit. Okay, however, we are not done. We still need to determine what the question asked us to determine: the change in the temperature. Okay, how did the temperature change from 19 to 25? Okay, the change in temperature would therefore be that 77 degrees Fahrenheit minus the 66.2 degrees Fahrenheit. If you punch that into your calculator, change in temperature, right, is going to be 10.8 degrees Fahrenheit. All right, and that is basically it. Okay. All right, so let's just quickly look at how they would mark this question, because that is very important. Okay, in question 3.1, you will get 2 marks for obviously giving the definition of the circumference, right? Okay, in question 3.2, you will get 2 marks, right, for obviously showing how you've basically converted from your 40 feet, for showing that 40 multiplied by 0.3048. Okay, you'll get 1 mark for that. You'll get another mark for your final answer of 12.192 meters. Okay, in question 3.3, you'll get 1 mark for converting your 25 feet to meters. You'll get 1 mark for converting your 6 feet to meters. You'll get 1 mark for obviously showing how you calculate the volume of section B, right? Okay, and obviously giving what the volume is. And they basically allocated another mark for obviously dividing by 2. You get another mark for that, right? And you'll get a mark for then getting that the volume of section B is 84,950 liters. Okay, you get another mark for now adding your volume for your section A and your section B. Okay, and then a final mark for saying her claim is correct. Okay, so I don't know what happened to my working out when I was obviously still continuing with the video tutorial, but I'm just going to show you what the marking guideline basically showed, how the marking guideline says that they'll mark this question, right? But please follow with the method that I basically gave you guys in terms of how you needed to calculate the volume of the triangular prism. Okay, please stick to that. That makes sense, not what is written in the marking guideline. Why did they continue to divide by 2 and not just showing it in the initial calculations? So I don't agree with that. Okay, right? And then let's basically have a look at how they'd mark question 3.4. You'll get 2 marks for saying B. Question 3.5, okay, you'll get 1 mark for converting the 65,000 liters to meters cubed. You'll get 1 mark for that, right? You get another mark for calculating or showing that the volume is equal to 3.142 multiplied by 2.5 all squared multiplied by your depth or your height. You get a 1 mark for showing that. Okay, you'll get another mark for showing that now the depth is actually equal to 65 divided by 19.6375. You get a mark for showing that. Okay, then you get a mark for showing that therefore your height or your depth is equal to 3.30999. You'll get a mark for that, and you get a mark for then rounding off your answer to 2 decimal places. Okay, so this question in total is out of 5. Okay, let's look at question 3.6. Okay, for question 3.6, you get a mark for now first calculating how much is 92% of 65,000 and getting that it's 59,800 liters. Okay, you'll get another mark for now basically converting your 59.8 meters cubed to the time that it would take to basically fill up those cubic meters. Okay, so by dividing by 1.5, you will basically get your mark there. Okay, you'll get another mark for saying it takes approximately 40 minutes, okay, for us to fill up the pool to 92% of its capacity, right? You'll get another mark for saying 8:10 a.m. and you get a final mark for saying her claim is not correct. Okay, so that question is out of 5 marks. Question 3.7 says the design. Okay, 3.7, they said that what is the reason why she could have went for pool A instead of B, right? So any reasonable explanation that makes sense. Okay, you will just get 2 marks for that. Okay. Question 3.8. Okay, calculating your temperature change. You'll get 1 mark for obviously showing that you need to basically first convert that 19 degrees Celsius to Fahrenheit. So you get 1 mark for 62.2 degrees Fahrenheit and showing how you basically substituted that into your formula. You'll get another mark for converting your 25 degrees Celsius to Fahrenheit. Okay, you're not going to get a mark for the formula anymore because at this point you know, so you'll just get 1 mark for saying 77 degrees Fahrenheit. You'll get another mark for obviously calculating the temperature change. 77 degrees Fahrenheit minus 66.2 degrees Fahrenheit, 1 mark. Then another mark for your final answer, right? And this question is out of 5. Okay, and guys, that is it for today's video tutorial. I hope you guys enjoyed question 3, right? I'm not gonna combine question 3 with question 4 because it's different topics. Okay, so I hope you guys enjoyed. I hope you guys are subscribed to the channel if you've made it this far. Please make sure that you also join or become a member of the channel if you appreciate the content, right? And if you also want me to prioritize any question that you have on the video tutorials that you watch on my channel, guys, please consider being a part or a member of the channel. And that is it for today's video tutorial, guys, and I'll see you guys on my next upload. In the next upload, guys, we are dealing with question 4, the whole of question 4. We'll be doing it. Okay, so see you then, guys. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.